Hey everybody, we're ready for 7.3, which is solving systems of equations by graphing. The solution to a system of linear equations, so a couple lines, could be more lines than that, but we'll just deal with 2 lines, is the point where the lines intersect. So if you're asked to find the solution to a system of equations, you're asked to find really the point where the equations intersect. Okay? So the first thing we're going to do in this section is just to verify or see if a point is a solution to a system. So we're asked to decide if the given ordered pair or the given point is a solution to the system. So in this first example, is the point 2, -4 a solution to this system of equations? Well, to see, we need to plug the point into both equations to make sure it works in both. And if it does, then it is a solution to that system. So I'm just going to do that. So 2 times x, which is 2, plus 3 times y, which is -4. We want to see if that's equal to 6. So let's see, 2 times 2 is 4, plus -12. Let's see, I don't know. Let's see, 4 plus... maybe I'll just do this out. 2 times 2 plus 3 times -4. I get -8. So that is not equal to 6, is it? So right away we could say this is not a solution to the system. Even if it works in the second equation, it's still not a solution to the system if it does not work in the first. Now if you check the second equation, if I do 3 times 2 minus 2 times -4, let's see what that is. So 6 minus or plus 8, yeah. So that does equal 14, right? So it checks with this one, but not with that one. So this is not a solution to the system. The answer would be no way. Not a solution. Because this -8 is not equal to the 6. Alright? Now we check the next one. Let's see. Is -3, -1 a solution to this system? Let's see. 5 times -3 minus 3 times -1. Let's see what that is. And you could use your calculator or you could use mental math, either one. So 5 times -3 minus 3 times -1. And that is -12. So that one works in this one, right? And then let's try the next one. 2 times -3 plus 3 times -1. Let's see if it works in this one. 2 times -3 plus 3 times -1. We get -9. Hey, it works in both. That's when we could say it's a solution to the system. So yes, in this case, it is. Now let's try the last one here. So we have 4 times 4 plus 3 times 0. Well, that's pretty easy. 4 times 4 is 16. 3 times 0 is 0, so that is 16. Works in the first one. Let's try the next one. X is 4 minus 4 times 0 equals -4. Is that true? Well, 4 times 0 is 0, right? 4, nope, does not equal -4. So, no for that one. If it doesn't work in one of them, it's not a solution to the whole system. So the answer would be no here again. So you'll see some problems like that in my lab. It's just plug and chug, make sure it works in both. If it does, it is a solution to the system. If it doesn't, it's not. Now, the other thing we're going to do is to find the solutions to a system. And there are basically 3 techniques we'll use to do that. This section is all about using graphing. So one option is to graph the system and see if we can find the point of intersection. So these 2 equations are both in standard form. With standard form, I like to use a t-chart. So I'm going to use a t-chart for both lines here. And we'll graph them and see if we can tell where they intersect. Okay. So if we find the intercepts, remember find the intercepts is one good way to do this. Plug 0 in for x. So we get negative 2y equals 6. Well, negative 2 times negative 3 is 6. So 0, negative 3 was on that line. Find the x-intercept. We put 0 in for y. And so this part goes away. We'd have x equals 6. So that's easy. 6, 0. So let's graph that line. And now I'll just find my little, oh, there it is. Find my little card. 0, negative 3, 6, 0. And then I'm going to make sure, and when you're finding a solution to a system, it's important that your line is straight. So it's even important to have a straight edge of some sort. Rulers would work, but any kind of card you have would work too. Alright, so let's look at the next one. Let's plug in 0 for x to find the y-intercept. This part goes away. We have y equals 2. Find the x-intercept. Put 0 in for y. 2 times 1 is 2, so x is 1. So I'm going to plot those points. The point at 0, 2 is here, and 1, 0 is here. And I'll connect those guys and try to make it straight as possible of a line that goes through those 2 points. And we're going to see if we can figure out where they're at. Now, because of human error, this may not fall exactly where it's supposed to, but it looks like they both intersect around about here, right? Right about there, which looks like it's the point 2, negative 2. So 2, negative 2 appears to be a solution, and then all we need to do is check in both equations to make sure it works. So let's see, 2 minus 2 times negative 2. Does that equal 6? So that's really 2 plus 4. Yep, that's 6, right? And then we try this one, right? 2 times 2 plus negative 2. Does that equal 2? So that's 4 plus negative 2, which is 2. So it does work in both. It checks out in both of them. So this would be our solution to the system. 2, negative 2. All right. And I think my lab will actually, they'll have these braces there for you, and you put the point inside. Okay. So you won't have to write them, or you want to type the braces, they'll already be there for you. But this is a solution set that contains that one point. All right, so I'm going to stop the video there, and we'll do a few more examples on the next page.